Hey guys, we got some good news. Mr. C is most likely going to be back this week. As I'm recording this, he is on his way back and is going through the process of getting everything taken care of all the requirements they have to do when they return. So I'm going to make a video for you introducing you to what is a system of equations and just hit some of the high spots for you. It's important that you watch this video as if it were your notes. And then Mr. C will pick up when he returns on the things that you are supposed to be learning along with this. You do have a test on solving equations and inequalities this week. A-day students, by the time you watch this video, you may have already taken that test, but B-day students, when you return to school, you will be taking that. So make sure that you are reviewing your notes from solving equations and inequalities. But today we're going to talk about what is a system of equations. Now, you have learned about just equations in general, and you learn how to graph things in slope-intercept form. Remember y equals mx plus b? Well, now we're going to do some things like that, but a system of equations is when you have two or more equations that are requirements for one specific scenario. And we are only going to be looking at linear equations, meaning ones that make straight lines. As you go through your high school career, you're going to look at some systems of equations that don't make straight lines. But for 8th grade, we're only concerned right now about the ones that do make straight lines. And so I've started this off with a little word problem. It's very easy to figure out the answer without doing any of the methods that we are going to be learning with systems of equations. But I just want to kind of give you a scenario to show you how system of equations work. So just a little mini word problem. Again, it's not complex and it's nothing like it's going to save the world if we solve it, but just kind of show you how this goes. So let's say you're told you have 7 coins, only pennies and nickels, and it totals 15 cents. And we want you to figure out how many pennies and how many nickels you had. Well, we know that you could make a chart. We know that you could just play around with numbers in your head and figure this out. I'm going to start by making a chart for you. So I would start by saying, okay, well, what if I had 1 penny? And that would leave 6 nickels in order for us to have a total of 7 coins. How much would that be? So 6 nickels would be 30 cents plus 1 penny. That would be 31 cents. Then I could have 2 pennies and 5 nickels. So that would be 27 cents. Or 3 pennies and 4 nickels. And that would be 23 cents. Or 4 pennies and 3 nickels. And that would be 19 cents. Or 5 pennies and 2 nickels, which would actually be the 15 cents that we needed. So by making a table, we are able to figure out that we have 5 pennies and 2 nickels. Now, you can do lots of things like that with a table and figure out, guess and check. But the bigger the parameters are, the harder it's going to be. Also, if I was including more than just pennies and nickels, like quarters and dimes, and then it gets a little bit more complicated. Now, I told you we're only going to be looking at linear, so it's not that big a deal. But you could come up with a system of equations. And the way this system of equations work was say, okay, we got 7 coins, that's pennies and nickels. So I would say the number of pennies plus the number of nickels has to equal 7, whereas P stands for the number of pennies, N stands for the number of nickels. And then I also say, okay, well, I know each penny is worth 1 cent, so I'm going to multiply the pennies by 1, and each nickel is worth 5 cents, so I'm going to multiply the nickels by 5, and that has to equal a total of 15 cents. And then if I graphed those two equations, now I know that's not in slope-intercept form, but we could put them there, but we're not stressing about that now. If I graphed those two equations, when I graphed them, where they would cross would be at 5 pennies and 2 nickels, and that's how we would get our answer. So I want to show you the first method you're going to learn when solving a system of equations is graphing. And so there are 3 scenarios that you could have. The first one is when you graph these lines, they could intersect at one spot, like so. That point of intersection is called the solution. So whatever the x value and y value is at this point would be your answer. So if we were going back to the pennies and nickels problem, you would say that x was maybe the pennies and y was maybe the nickels. And so our ordered pair would be 5, 2, because it was 5 pennies and 2 nickels. So the ordered pair of what is where they intersect would be your solution. And this is when there is only one solution. Now, sometimes there are word problems, and once we get to looking at them and we graph them, The two lines are parallel. And if two lines are parallel, they're never going to cross. And so what that tells us is there are zero solutions or no solutions. And what that would be is if we had gone through every combination of pennies and nickels possible and they never equaled 15 cents, then we would know that there was no solution here. That would be example when we graphed it, it would be parallel lines. And then the last type you can have is if you graph this and you graph the first line and it looks like that, and then you graph the second line and it is actually the same exact line, just one was in a different form, like maybe one was in slope-intercept form and one was in standard form, which we'll talk about another day. But if that's the case, this has infinite solutions. And what infinite solutions means is that every point that is on that line is an answer. It doesn't mean every answer in the world, but every point that's on that line. So for instance, if this point right here was 0, 5, then 0, 5 would be an answer. If this one was 1, 7, that would be an answer. If this was negative 2.3, 4, that would be an answer. Any point that's on that line. So we have three options. There can be one solution, which means the lines cross at just one point. There can be no solutions, which means the lines are parallel, or there can be infinite solutions, meaning the lines are on top of each other and every single point that is on that line is a solution to the problem. Most of the problems we want to deal with, we want them to have one solution. But occasionally there are word problems that there are no solutions for, and occasionally there are word problems that every combination that you look at will work. And so I just want to do one graphing problem with you here by hand, and then I'm also going to do it with you on Desmos the calculator, and then we'll stop for today. So these two are both in slope-intercept form. Now I want to remind you y equals mx plus b. Remember, b is your y-intercept and m is your slope. So if I draw a graph over here to the side, now normally on a test we would give you a graph because we know it's kind of hard to get one exact when you draw by hand. And I'm just going to fill in a few tick marks. And I'm going to graph the first one, y equals 1x minus 2. Now you might say, Ms. Dix, there is no 1 in front of it. Well, remember, if there's no number there, it's an invisible 1. So my y-intercept is negative 2, so I go down here to negative 2 and put a point, and my slope is 1. So I go up 1, over 1, up 1, over 1, and that is my line. I'm just going to keep going up 1, over 1 for a few points, just because the more points we have on our graph, the more likely it is we run into our solution. And I'm eventually going to put an arrow on this side as well, but I kind of want to see what this other line does first. So when I look at the next one, it has a y-intercept of 4, so I go up to 4, put a point, and has a slope of negative 1, which means I go down 1, right 1, down 1, right 1, down 1, right 1. And I can see right there that these two lines cross if my graph is straight, which is difficult sometimes, but they cross, it looks like to me, at 3, 1. I don't know why I put negative 1 there. Ignore that. This is supposed to be 3, 1. So what that tells me is our solution is 3 for the x value and 1 for the y value. Now I know this has one solution because they only cross at one spot, but if I wanted to check this, what I would do is I would take those numbers and put them back into the original equation. So for y, if I have y equals x minus 2, I would put 1 in the x spot and 1 in the y spot and 3 in the x spot, and ask myself, does 3 minus 2 equal 1? Yes, it does. So it works for the first equation. So then I have to check the second equation, y equals negative x plus 4. So again, I put 1 in the y spot and 3 in the x spot. Does negative 3 plus 4 equal 1? Yes, it does. So I know that 3, 1 is the solution to this problem. Now, I know that was fast to go through, but you just need to realize to find the solution, you're going to graph both lines and figure out where they cross. That's it. Now, sometimes figuring out where they cross is a little more difficult because it's a fraction or a decimal, but the ones we're going to start with are not going to be fractions and decimals. Will we eventually get there? Yes, but we're going to work our way up with baby steps. Now, these two just happen to be in slope-intercept form, and that is great. That's the one that we want. But sometimes it's going to be in another form. So I want to show you Desmos. So Let me change screens here. Here's Desmos, and Desmos is desmos.com. It's an online calculator. Hopefully you've seen it before. When you type that in, there's going to be a little blue button there that says go to graphing calculator, and you want to click that. So right over here is where you type in your equations. Now, sometimes we use Desmos just to add, subtract, multiply, and divide, like 3 plus 8. Oops, I hit the wrong thing. 3 plus 8, and hit enter, and it tells us there's your answer right there. But sometimes we want to use it to graph, and here we're going to use it to graph. So I'm going to type in my first line, y equals x minus 2. And if you notice over here in green, it is graph, the first line that I graphed on my graph by hand. And then I'm going to type in the second equation, y equals negative x plus 4. And in blue or purplish, it's graphed the other line that I graphed. Now I'm just going to show you here. See, that looks very similar to what I graphed. And so where they cross will be your answer. And look, if I hover my mouse over that point of intersection, it pops up 3, 1 on the screen, which tells me that the intersection is 3, 1, which is exactly what we got. So Desmos you want to use to check your answers, or you want to use it to do the graphing for you if they don't make you graph it by hand. Now, one good thing about Desmos is you can type in equations in any form. So if they happen to be in a form that's not slope-intercept form, this will graph it for you. So these are two different forms we could see, and look, we just hover over and our solution is 1, 1. So Desmos is going to be your friend. Sometimes your teacher may tell you you can't use it. Sometimes your teacher may tell you you can. On SC Ready, you'll be able to use it on most of the tests. There is a part you won't be able to, and the state of South Carolina decides that for us. So just to recap systems real quick. It's where you have a word problem where there's normally at least 2 parameters, like I did the number of coins and how much it totals. Then you have 3 options for answers. If they cross like this, there's only one solution. If they're parallel, there's no solutions. And if they are the same line, one sitting on top of each other, it's infinitely many, which means any point on that line will work. The first method of solving systems is by graphing. We are going to learn 2 more methods, substitution and elimination, and they are a little bit complicated and use some algebra type steps. So you're just going to have to hang in there and work your way through it. But always remember, you can always use Desmos to graph it, and it will give you the same answer as whatever method you're trying to use. But they can use some multiple choice problems that make you go through those methods. So keep that in mind. But Desmos is always something you can fall back on to check your work or to find an answer if it's multiple choice. The other type of question is they could say how many solutions. So in this case, if they said how many, I would just say there's one answer. They are not asking me for the answer, just asking me how many. If it was parallel, I'd say there were 0. And if it was the same line, I would say there's infinitely many. So just to show you one time what it looks like with the same line. When you graph it, you're only going to see one line on the screen. And notice right now it's red. If I touch the other equation up here, notice it turns green. You can see that they are in the same spot on top of each other. So that would tell us that they are the same line. So I hope this helps, and look forward to seeing how you do with systems.